Okay, so now that we've talked about localization, I'm going to talk more about modularity. So, modular systems, as I mentioned in the previous video, they're often hierarchically arranged, meaning that, one subsystem does something and then spits that information into another subsystem and then spits it into another subsystem, right? But they're hierarchical in the sense that, module three can't do its job without module two and module one doing their jobs. They also break down into subsystems. Modular systems break down into subsystems, and these subsystems exhibit modular characteristics. So now I'm going to talk about some of those modular characteristics. So, um, so the first one is called domain specificity, which is just sort of a fancy word for saying that the modules are highly specialized. They can only do certain things, and that's all they do, right? So their mechanisms, the mechanisms are designed to carry out very specific and circumscribed information processing tasks. Because of this, they only operate on a limited range of inputs, those inputs that are relevant to whatever that domain is. The other thing is they display what's called informational encapsulation. And this just means that modular processing is not affected by what's going on elsewhere in the mind. So the modules cannot be infiltrated by background knowledge and expectations or by information in other in other different modules, right? The other thing, and we're going to talk about that in a second with these visual illusions, perceptual illusions that I'm going to show. The other thing is they show mandatory application. So that means that the modules are mandatorily applied, right? So that just means cognitive modules respond automatically to stimuli. They are not under any executive control and cannot be switched off. It is evidence that certain types of visual processing are module the evidence for that is that we cannot avoid perceiving certain perceptual illusions even if we know them to be visual illusions. So again, I'm going to talk about that in a second. And then finally, the thing that modularity buys you is speed. So modular processing transforms input into output, and it does this in a quick and efficient way. So what do I mean by transforming the input into output? If the input is patterns of intensity values picked up by photoreceptors in the retina, well, the processing transforms that into output or representations of three-dimensional objects in a quick and efficient fashion. And as I mentioned, modularity addresses the problem of how we can do such complex cognitive functions so rapidly, even though they're computationally difficult. So to explain some perceptions that might be modular, it's what's called the Mueller-Lyer illusion. So I'm going to show you. Notice how these two lines, they're of the same length, right? And I'll show that I'll put some vertical lines just to show that to be true, right? Okay. Now the interesting thing is if I put these arrows on each line like this, right? What you'll probably perceive as, you'll probably see that the top line is longer than the bottom line, right? Now, I just showed you that they're of the same length, and I'll show you again. They're of the same length. But when I get, and so despite you knowing that the two lines are exactly the same length, you still are tricked, right? And this shows that your beliefs have no influence on your perception. The module doesn't, whatever module is involved in this perception, it doesn't listen to our own beliefs. And so, in other words, whatever module is involved in constructing this perception, whatever module is involved, it's informationally encapsulated from our beliefs. It is also automatic in that you didn't decide to perceive it this way. The module was applied in a mandatory fashion. And so this illusion suggests that perceptual systems are not cognitively penetrable. And cognitively penetrable just means that our beliefs do not penetrate these modules and don't penetrate the perception, right? Here's another one. It's called the monster illusion. And if you look at this, you'll probably perceive the farther away monster as being larger than the closer monster, right? Well, I can get rid of the background and you can see that now the two monsters are of the same size. However, if I go back and put this context in, you're likely to still be tricked by this, right? So again, illusion suggests that some of our perceptual systems are not cognitively penetrable just because of the fact that your beliefs were not capable of penetrating this this perceptual illusion. And this is also true with the shepherd tables. The shepherd tables, now I don't really get it. I still don't really see it. But apparently, if you rotate the left table to match the right table, you will find that the left table and the right table are of the same length. And again, this is one of those examples in which our perceptual system is not cognitively penetrable, or is the modules are informationally encapsulated because our beliefs are not capable of changing our perceptions. Okay, in the next video, we'll talk about domain specificity.